Nelson used 35% of his savings to buy a new bike. If the bike cost $140, how much was in his savings account before he bought the bike? So it's telling us that the bike cost $140, and it's telling us that he didn't use all of his savings to buy that bike. He only used 35% of his savings. So in this problem, 140 is not 100% because he didn't use all of his savings. He only used 35% of his savings. So he used 35% on the bike, so he used $140. Our goal is to figure out how much was in his savings account before he bought the bike. So we're trying to figure out the 100%. So usually I try to get down to either 5% or 10%, sometimes 20%. In this case, I'm going to get to 5% because to get to 10%, it wouldn't be an easy scale factor. So to get to 5%, I'm noticing I'd have to divide by 7. So that means this has to divide by 7. Now 14 divided by 7 is 2. So 140 divided by 7 would be 20. So $20 is 5%. Again, I like getting to 10%. I know I could get straight to 100, but I think I have less errors if I get to 10%. So I will double each side and get 40 is 10%. And now it's really easy for me to get to 100% by timesing by 10. 40 times 10 is 400. So 400 was in his savings account. Tanya got a great deal on a TV this weekend. She paid $320 for a 72-inch TV. If the TV was on sale for 20% off, what was the original price of the TV? So she didn't pay full price. So the $320, again, is not 100% because she didn't pay 100% of the price. In fact, the whole TV would be 100%. They're taking 20% off, which means she's actually paying 80%. So when she paid $320, she was paying for 80% of the TV. From there, we need to figure out the original price, so that would be the 100%. Now, since 80% ends in a 0, this time I'm going to get to 10% because the scale factor won't be too bad. To get from 80% down to 10%, I would simply divide by 8. So over here, I'm going to divide by 8. Now 32 divided by 8 is 4. So 320 divided by 4, or divided by 8 would be 40. So we want to get to 100%. So times by 10. And we end up with the original price is $400. So 400 seems to be our lucky number in these problems. All right, Tanner collected 360 cans and bottles while fundraising for his basketball team. This was 40% of what his friend Reggie was able to collect. How many cans did the two boys collect together? So when I'm reading this, it's talking about the two boys collecting them together. So that means Tanner's cans and Reggie's cans. Now we already know Tanner's cans. It says Tanner collected 360, but we don't know how many cans Reggie collected yet. So our goal right now is to figure out how many cans did Reggie collect. It gives us some information to find that. So it tells us that Tanner collected 40% of what Reggie collected. So when it says this was 40%, it's saying 360 is 40%. And I'm trying to figure out the 100% because that would represent Reggie. So to get from 40% to 100%, I'm going to get to 10% by dividing by 4. Okay, 36 divided by 4 is 9, so 360 divided by 4 would be 90. And then to get to 100%, we would times by 10. And that would be 900. So that's representing Reggie's cans, because Tanner only collected 40% of the what Reggie did. So Reggie collected 900 cans. So we're not really quite done with the problem yet, because the problem wants us to know how many cans did the two boys collect together. So we have to take our 360 and add the 900 from Reggie, and we would get 1,260 cans. So this problem is a good example of you have to do something more with the number once you find it. So it's not just getting to 100%, but then using that amount.